Today's lesson, section 9.5, we'll be talking about the cross product. So if there's a vector A and a vector B are three-dimensional vectors, then the cross product of vector A and vector B is the vector, which is the following. Now, looking at this is your component for x, component for y, and component for z. Now, those look kind of confusing, but what they're doing is they're taking our 3x3 determinant and comparing them to what is the outcome. So this is actually what they started with, and they're just writing it in component form at the end. So like for the I part, you would take a squared, or a sub 2 times b sub 3 minus a sub 3 times b sub 2. Okay? And so that's one way of doing it. How I'm going to use like the 3x3 matrix way and write all my stuff in IJK form because it's a little easier to me, but you can also use the format shown above if that's easier to you. Don't feel like you're forced to do one or the other. Okay? So example 1, we're given a vector for A and a vector for B. We want to find the cross product, so doing the cross product of these two. Okay, so then now when I put this in, remember the first vector in the cross product value is first, so 0, -1, 3, but certainly you could switch that order around and you'll still get the same thing. Okay, so then now the only requirement here is that you can't choose what row or column you want. You want to use the first row. Okay, and that's kind of the only requirement here. Everything else is very similar. So I will take those values in the submatrix, so cross out your row and your column for I. That leaves you with -1 times -1 minus 0 times 3. Now I'm going to write my I, J's, and K's at the end. Now J is in a negative position, so I'm going to write the opposite sign, so negative there first, but I'm going to put the J at the end of the parentheses. And then J, cross out its column and its row, so that takes you 0 times -1, and then minus 2 times 3, and then J, and then plus the last one, K. So cross out the column and row that K is in, so that's 0 times 0 minus 2 times -1. Okay, so now I want to simplify. So then -1 times -1 is 1, minus 0, I, minus 0, minus 6, J, plus 0, plus 2, K. So then here, that gives me 1 here, that gives me -6 here, that gives me 2. So double negative here makes that go away, so 1I plus 6J plus 2K. And this would be the vector for my cross product. Okay? Remember, cross product is a vector. Now, cross product theorem says that if you have a cross product of two vectors, it is orthogonal. So that vector is orthogonal or perpendicular to the two vectors that are separate, that made up the cross product. So here, example 2 wants you to find the unit vector that is orthogonal to vector A and vector B. So that just means that they want you to find the cross product and then divide that by the magnitude of the cross product, because remember, that's how we find unit vectors. So first we need to find the cross product. So I, J, K. So then here 0, 2, 3 would be vector A. 4, -1, 2 would be vector B. And so then now for i's, it's going to be 2 times 2 minus -1. Let's do 3 times -1. Doesn't matter the order. I minus j's in the negative position, so 0 times 2 minus 4 times 3 j plus 0 times negative 1 minus 2 times 4 for k. So then that leaves me with 4 minus a negative 3, so that's actually plus 3, alright, and then minus 0 minus 12, j, and then plus 0 minus 8k. So here, double negatives make that come positive, so that gives me 7i plus 12j minus 8k. Okay, so there's my vector for my cross product. Now I still need to find my magnitude. So 7 squared plus 12 squared plus negative 8 squared. So that gives me 49 plus 144 plus 64. If I add that all up, it gets me 257. Now, 257 doesn't have any reducible values to it, so I can't take anything out. There's no square roots. So it's just a prime number, so I'm just going to leave it as that. So then when I write my unit vector, I read it right in this form, so I can write it as this. Okay. Also remember that that's not the only way. Okay. You could also write it as in component form, so 7 over square root of 257, especially if you did your cross product in component form. Okay, so either answer would be correct in this sense for the unit vector. Okay. Okay. Next example, we want to find a vector perpendicular to the plane that passes through the points P, Q, and R. Okay. So first, we want to find something perpendicular. We want to do the cross product here, but we need to find the vectors first before we can take the cross product. So I need to find two vectors using these points. So let's do PQ and PR. So that means that Q and R are my terminal points, and then P is my initial. So that means that I get negative 2 minus 1, 5 minus 4, and negative 1 minus 6. And then for PR, I get 1 minus 1, and then negative 1 minus 4, and then 1 minus 6. Okay, and so that gives me negative 3, 1, negative 7, and then the other one would be 0, negative 5, negative 5. Okay, so using those two vectors, now I need to take the cross product of them. So I, J, K, negative 3, 1, negative 7, 0, negative 5, negative 5. Okay? So first one for I would be 1 times negative 5 minus a negative 5 times a negative 7. I minus be negative 3 times negative 5 minus 0 times negative 7, j, plus, and then it would be negative 3 times negative 5 minus 0 times 1, and that would be for k. So then now, simplifying that up, -5, and then this becomes 35, but then there's minus 35 there. Minus, it'd be 15, minus 0, j, and then it'd be plus 15 minus 0k. So simplifying that would give me a -40i minus 15j plus 15k. And so then that would be the perpendicular vector to those points in that plane. Okay. Now the next thing to talk about is the length of the cross product. So if you have an angle, and so this angle theta is between two vectors a and b, so in between, like in theta is in between 0 and pi, it can be 0 and pi, then the cross product of a and b is going to be the magnitude of a times the magnitude of b times the sine of theta. Okay, so that's how we'd find the length. In particular, if there are two non-zero vectors for a and b, then they are parallel if and only if the cross product is 0. So if you found the cross product is 0, that means that they're parallel, so it means there is no angle in between them, because they don't intersect to create an angle. Okay. So here also another thing is the area of a parallelogram. The length of the cross product is the area of the parallelogram determined by vector A and vector B. Now also note that half the area of a parallelogram is also the same as the area of a triangle in that same plane. Okay? So for this next example, that's kind of what they're asking. They're wanting you to find the area of a triangle with these vertices. Now if you notice these points, I picked them particularly for a reason. They look familiar, right? They were the ones that we used for example 3 when we were looking for a plane, like a vector in the perpendicular plane. So if I want to find the area of a parallelogram, I just need to find the magnitude of the cross product, but we already found the cross product for this one. It was the -40i minus 15j plus 15k. But also remember, go back to that formula that they gave. Okay. Now it's not just one side. The length of the cross product is the magnitude of the cross product, or the magnitude of A, magnitude of B times sine of theta. So if you had the angle, which we don't, or right now we could find it, but we don't have it right now, and we could do that. But we already have the cross product for this problem, so all we need to do is find the magnitude. So the magnitude of this cross product would be, now -40 squared would be 1,600 plus 15 squared is 225 plus another 225. Okay, you add those all together, that gets you 2,050. Now we can simplify that to 5 square root of 82. Okay, now that's the area of the parallelogram. That was what the formula said, but we said note, half of the area of the parallelogram is that area of the triangle. So if I take half of this, that gives me the area of my triangle. Okay, so then 5 times square root of 82 divided by 2 is the value or the area of your triangle for these 3 points. Okay, have fun.